do we have yet? Some names up here, the field people are here, so has everybody picked up their homework and turned in today's homework? Please do so. I also have homework number 8 posted on Blackboard. This will be due a week from today. It'll be on Blackboard, so if you don't want to write it down, it'll be up there ready for you.
This is so bad.
Okay. That's all I had to do on Blackboard, I think. The quiz for next week is available through Sunday night, so you'll be able to take it anytime. So there should be plenty of time to go ahead and take the quiz. So homework and quiz is taken care of. Now what we want to do is start in with new material. What we're going to do is we had talked about single proportion and two proportions. And in terms of our text, this is module 3 that we're going to talk about. We're talking today about section 9.6 and parts of section 9.9. This is what we've talked about so far. We've been dealing with a situation where our response variable is categorical. We had either a simple population, so only one level that we're looking at, so we're looking at everybody in the population. That was a single proportion, and that was module number 1 in your textbook. So it's a single proportion case. Friday, we extended that to the case of breaking the population into two pieces and looking at the difference between two proportions. So that was module 2 in your textbook. What we're going to do today is we're going to take it this way. So we're talking about a quantitative response, and that means we're talking about means in this case. And once again, let's shorten this up a little bit. And in particular, we're looking at the simple case of a single mean. And so that is single mean, and this is module number 3 in your text. When we change the response from a categorical to a quantitative, remember that when we changed from the categorical to quantitative data type, a lot of things changed. We use different graphics, different summary statistics, and so forth. There are going to be a number of things that change when we switch from a quantitative or to a quantitative response from the categorical response that we've been working with. First thing is, when we start with this, we have a population just like we've always had. The thing that we're interested in the population is this mu. We go ahead and take our sample. In our sample, we're going to have x bar and n. So the first thing we have to do is, for this sample of size n, we're calculating x bars. if you want to think of a situation that this is like, think back to our rectangularity experiment where we were sampling from a population of rectangles. We're calculating average areas of those samples. That is exactly the situation that we're looking at here. We're going to have an X bar, and we want to know what that X bar looks like, how it acts. And so what we want to talk about today is essentially sampling distribution for that X bar under two different conditions. So let's start with our table first. We have a case of a single mean. So this is row 3 of the table. The parameter, as I said, is mu. What should the estimate be? Sure. Same thing as what we're looking at in the population, except calculated with the sample that we can actually get a hold of. So it's going to be X bar. There's going to be a standard deviation for X bar. That standard deviation is actually going to be simpler than the one we had in the previous two sections. It's simply sigma divided by the square root of n. Here's the first hitch we're running into. When we looked at a single proportion, this value is p, this value is p hat, calculated from the sample. This value was the square root of p times 1 minus p over n. So all we needed is p and the sample size. In this case, what's happened is not only do I have a sample size, but I've introduced a new population parameter. Whenever I'm dealing with a population mean, I'm also dealing with a population standard deviation. So again, think back to the rectangularity experiment. We were interested in the mean of that population of rectangles. We also calculated the standard deviation, and that came into play in a couple places. It will play here as well. So we now have a second parameter to deal with. There will also be in the sample a sample estimate for that parameter. Okay? So we're interested in this population mean, but in order to do anything with that population mean, I either need the population standard deviation, or we'll see that we'll be able to use this S in certain circumstances. Okay?